Hello everybody, my name's Tom. This is my first time at DevOps-Exchange, so be nice to me. I'm going to talk about Kubernetes and Prometheus. So we'll do a bit of audience participation. I won't make you stand up because it's hot. Who here is using Kubernetes? Hands up if you're using Kubernetes. Okay, that's not bad. What's that, 25%? And how about who here's using Prometheus? Is it the same people? Keep your hand up if it's both. It's mostly the same people. Okay, well, you can leave, because you know all this already. My name's Tom. I am the VP product at Grafana Labs, but I'm actually an engineer. They bought my startup about 4 or 5 months ago, which was Kausal, and gave me a posh title, but I sit in front of my desk and do coding all day. Is this being recorded? It is, okay. No, I do VP product stuff. And yeah, at Tom Wilkie, Tom_Wilkie, if you want to tweet me. Last time I gave a talk, I was at 980 followers, and now I'm at 1,000 and something. So you don't actually need to follow me. I've reached my life goals. So the agenda is going to be really brief. We're going to talk about Prometheus for the 75% of people here who don't use it. We're going to talk about Kubernetes for that same 75%. Then we're actually going to get into the meat of what I really want to talk about, which is how we combine the two and how we can do some really cool stuff. And then there's a few links at the end for if you really want to get started. What is Prometheus? Well, it is a monitoring system. It is not a time series database. It is not a alerting thing. It's a monitoring system, so it involves a lot of different components. It was inspired by a piece of software called Borgmon, which is was Google's internal monitoring tool for monitoring Borg. It was built by some chaps at SoundCloud, who are, some of them are still involved in the project. It is open source. It's now part of a foundation called the Cloud Native Compute Foundation. This is all a bit backwards, this talk, but it'll make sense. So Borg and Cloud Native Compute will all make sense in a minute. So what differentiates Prometheus from the rest of the monitoring systems has a very simple text-based metric format. So it's very easy to get metrics out of different systems. It has this really flexible multi-dimensional data model. So unlike who here's heard of Graphite? Hands up? Okay, way more people than Prometheus. So Graphite has a hierarchical data model. Prometheus has a multi-dimensional one. This is powerful, but also quite simple. And then we've got this really cool query language, which allows you to kind of turn all the metrics and data that you scrape into some really useful information, which I'll give you some examples of later. What is it good for? Well, monitoring, graphing, time series database type stuff. It is really good if you've got fast-moving infrastructure. And what do I mean by fast-moving? If the jobs you're running change rapidly, if you're doing continuous deployment and you're deploying 10 times a day or 100 times a day, Prometheus is really good because it has service discovery. You don't have to statically tell Prometheus where the jobs you're monitoring are. Prometheus will go and discover them for you. It's not good for logs. It's not good for events. It's not that kind of system. It's dealing with aggregate metrics. So I said a lot of moving parts. This is pulled straight off the open source Prometheus docs. The Prometheus server, what we mostly call Prometheus, is in the middle and mainly consists of a time series database. And then I talked about service discovery and retrieval. But we've also got all of these other things which are really part of Prometheus. So first off is the integrations with third-party systems. Not everything exports Prometheus-compatible metrics yet, world domination. But for the things that don't, there are exporters. I counted this morning, there's about 120 exporters that integrate with pretty much every database you've ever heard of, every storage system, every switch, you name it, every format there is, even most other metric systems. So you can scrape data out of other monitoring systems. Then you've got, I talked about service discovery briefly. You've got the alert side of things. Now, the alerts are actually evaluated inside Prometheus, but Prometheus tries to keep it really simple. It tries to just say whether an alert is firing or not. And then all of the kind of, well, who should I send this alert to? Should I repeat it? Should I group it? Should I build more intelligence around the alerts? That's handled by something called Alert Manager. So Alert Manager would also do things like silencers. This is really useful when somebody turns up a new cluster, which is always broken because it's new. And you can just go into Alert Manager and say, silence that whole cluster. And then I like to include Grafana, and Prometheus likes to include Grafana in the ecosystem. And so this is from the company I now work for. And this is a visualization and dashboarding piece. But this together is the Prometheus monitoring system. I talked about this simple text format. I'm going to talk quite quickly because I've only got 20 minutes. But if you do want to interrupt, if something's not clear, just stick your hand up. We talked about this simple text format. Hopefully everyone can read that. I'll give you a couple of minutes. No, I won't. But yeah, it's really simple. Like you basically say a metric name, some tags that identify this given thing, and then its value. And then the Prometheus server will, this is just running on my local machine, but the Prometheus server will periodically scrape that target and record those values with the timestamp of when it was scraped. And then I talked about a really powerful and concise query language. This is one of the things that really differentiates Prometheus. So I'm going to walk you really quickly through the power of this. Prometheus data model is very simple. You saw those identifiers, those label sets inside curly brackets. That's an identifier. And then the time series is just a set of time, comma, value, like a list of time, comma, value, and we're indexed by time. Timestamps in milliseconds, blah, blah, blah. Prometheus identifiers, as I said, kind of look like this. So this would be a very typical HTTP server, would expose the total number of requests. So this is an ever-increasing, oh, the counters aren't on here, but this would be an ever-increasing counter. And then we might add some labels that say, well, it's for a given job, it's for a given instance of that job, because we all live in a cloud-native world and we're all running 20 web servers that do the same thing. It's for a given path and a given status. You know, these are successes when they fetched home, these are failures when they fetched home. And then we can come along with the Prometheus query language and have a selector which says, please return me all the time series that have a name, HTTP request total, have a job nginx, and have a status that matches the regular expression 5 ... So these are all the failed ones, right? So this is useful. These will give us all of the values. So there have been 34 failed requests since that server started. Right, these aren't rates yet. These are totals, and so on. So then we might come along and say, well, I actually want to know the rate at which this is happening. I don't care about how many in total has happened. I want to know if it's happening now. So we can take a vector. This would be give me all of the values for the last minute. So now we get this array. There's 4 entries in the array because by default Prometheus scrapes at 15 seconds. And then we can apply the rate function. And the rate function will come along and will effectively just differentiate that. And for people who don't know what differentiation is, it takes the first one away from the last one, or the last one away from the first one, and gives you a number. And so this is, there are 2.4 failed requests per second to the settings page. And then we can sum those by path. So this erases the instance ID. So we can tell for the entire service that settings is failing 3.3 times a second. And these numbers are correct. I went through and checked the slides and checked these all make sense. And then lastly but not least, we can divide that by the sum of the entire metric, which is all of the requests going to the system. And this gives us the error rate, right? This gives us the rate of errors to these different paths. And we can see that home fails 0.1% of the time, whereas settings is failing all the time. And so this is a really quick example of how, in Prometheus, you can take some really simple data, like the number of requests that have failed, the number of requests that have succeeded, across a distributed system with multiple instances, across different paths in your HTTP server, and get to what is now really quite actionable information. So I rushed through that because I also want to talk about Kubernetes. Let's talk about Kubernetes. So Kubernetes is a platform for managing containerized workloads. You can hear it. Kubernetes is such a big system nowadays and does so many different things that there's so many ways of describing what it does. Quite often people are talking about it as an operating system for your data center, the kind of piece of software you install on a few thousand servers, and it gives you a single API endpoint where you can just treat those few thousand servers as a single machine. So that's quite common. People also see it as a cloud abstraction layer where you can go and install Kubernetes on Amazon and install it on GCP, Azure, DigitalOcean, and then you just treat all these different clusters as if they're the same piece of software. That's exactly what we do at Grafana Labs. We run on all those clouds. So it does a whole bunch of different things. It's inspired by a system called Borg from Google. You'll notice that Prometheus was Borgmon and Kubernetes was Borg. So this is Google's internal cluster management system. And this is also part of the CNCF. In fact, the CNCF was set up to house the intellectual property in the community around Kubernetes. So to make it so that Google wasn't like, a benevolent dictator, it is now an independent third-party thing. And Prometheus was the second project that was added to that. This gives you a kind of idea about the relationship between these two projects. So, Kubernetes is awesome, it's distributed, it's fault-tolerant. It has this is what I'm going to focus on actually in this talk. It has a really rich data model for describing your application. So you want to say, well, we'll get to that actually. Oh, and lastly but not least, people here heard of Mesos? Hands up. Wow, more people. Okay, that's interesting. And Mesos, there was also Docker Swarm. We were having a chat earlier about HashiCorp something, Nomad. Like, so Kubernetes won. Like, I'm sorry. Get over it. So this is the basic Kubernetes architecture. As I said, Kubernetes exists, you know, in this constant state of flux. There's always new components coming and going, and I can't keep track of the hundreds of components involved in Kubernetes. But at your very basic architecture, you've got a master. Sorry, I'm from up north, so I say master. You've got a master. It runs the API server. This is the thing that gives your end users a command line that they can type stuff into. It runs a few services. So it's basically disaggregated the functions of the master into a scheduler, a controller manager. If anyone remembers the, I can't remember what it was. There was a paper by Google where they talked about how they disaggregated the scheduler out from Borg. That's inspired this architecture. It begins with an I think. No, don't worry. A friend of mine worked on it. Anyway, Etcd, this is your state store. This is your consistent, Raft-based store from CoreOS that pretty much the whole state of this object model that I've talked about gets written to. And then on each individual node, this is where your jobs run. You have Docker, which isn't in this picture. That's strange. But Docker will be running your pods. You know, pods are collections of containers, so Docker runs those containers. And then you have a few other things. You have the kube proxy. This is their programming IP tables to make your services magically load balance. You have the kubelet. This is the thing that's coordinating with the master to figure out where the pod should run, or rather be told where the pod should run. And cAdvisor. And cAdvisor we're going to talk about later. One of the things that differentiates Kubernetes from, I guess, Nomad and Docker Swarm, at least early versions of Docker Swarm, is that all pods live on a single network namespace. So a pod gets an IP address, and you can talk to any other pod in the cluster. You know, there's security rules you can put in place, but by default, you can talk to anything. So these networks are, you know, on your cloud provider, they're provided by your cloud provider. But if you run on your own hardware, there's Flannel, there's Weave, which company I used to work for got famous for. And they're the main moving parts. Now, one of the really interesting things about Kubernetes is from almost day zero, all of these moving parts exported Prometheus metrics in that format I showed you earlier. And that's why I showed you a big wall of text. All of these moving parts export really interesting data in Prometheus format. So you don't need any adapters, you don't need any exporters when it comes to Prometheus. Kubernetes. So I talked about this object model. These boxes now do not represent processes running on your server. These boxes represent ideas, concepts. This is almost a UML diagram. So in Kubernetes, the core concept, as you can see, because almost all the arrows point towards it, is a pod. And a pod is a collection of containers that get scheduled atomically on the same machine in the same network namespace. And then you can have an arbitrary number of containers in there, but typically you have like one main container that's like the memcached instance or the console instance that you want to run. And then you put some other stuff in there. You maybe put some bootstrap or some monitoring code or an exporter or something like that in there. Then you might say, well, this is not particularly useful because I don't want to just create one pod on my Kubernetes cluster. You know, I'm building distributed systems here. I want to create a service that consists of multiple pods, n pods. Let's say I want a service with 10 pods. Well, what you do is you create a deployment. And a deployment will create you a replica set, and the replica set will make sure there's always 10 pods running or n pods running. And what's more, the deployment abstraction allows you to do continuous deployment of that particular service because it will allow you to change the version and it will manage the rolling upgrade one by one of all the components in that, of all the pods in that service. Similarly, a stateful set is a very similar concept, but for stateful jobs like Cassandra. And a daemon set is the similar concept, but a daemon set is saying, I want this pod to run on every single machine. So what this really is, like, I won't get into the details any more than those examples. What this really is a model for describing the intentions of the architecture of your application. This describes to Kubernetes how you want Kubernetes to run your application. You know, if you're following Google Next, which was on the past few days, might still be on, in fact. This model goes to many orders of magnitude more complicated. You know, we're getting into serverless, we're getting into CI/CD, actual build pipelines running on Kubernetes. Anyway, yeah, so abstract model for how you want to run your application. This is really key to this whole talk. Now, CubeState Metrics. You know I said you don't need an exporter to monitor Prometheus, to monitor Kubernetes? Well, I lied. This is the only exporter you need. It's called CubeState Metrics. It takes that model, it takes all the objects in that model, and exports interesting information about that model. So in this particular one, it's exporting the labels associated with a deployment. But it will also export the number of containers in a deployment, or the number of times a pod has restarted, or the amount of memory a pod has asked for, and so on. Like, it just takes all of any number in that object model gets exported in an appropriate time series. Really cool project. If you've got a Kubernetes cluster that's not running CubeState-Metrics, what are you doing? So another project from Google called cAdvisor, Container Advisor. This, again, is another exporter. This is built into Kubernetes by default. I think it's linked into the kubelet in many versions of Kubernetes. And this will export information about the resource usage of your container. So it will tell you how much an individual container is using in terms of memory, how much CPU an individual container is using. It'll also do things. Just today, actually, I was using a bunch of cAdvisor metrics because we were seeing some performance issues on our memcached cluster, and cAdvisor will export statistics from the scheduler. So it will tell you how many times it got throttled, how many times did we have to reschedule that pod because it reached its allowance. So this is really good for resource usage metrics. Right, now that's the introduction over. How long do I have left?
A few minutes.
Great. Now we're going to talk about how we combine these two. This is supposed to be a 40-minute conference talk, so I tried to trim it down, but we're going to roughly structure this section into three things: the use method, the read method, and the I don't have a name for this method yet. Use methods by a chap called Brendan Gregg. Basically says for every resource in your system, you should be monitoring utilization, saturation, and errors. Utilization is quite easy. It's how much of this resource was used in that given time window. Saturation is how much of the resource did they want to use. So saturation can be more than 100%. You'd be very familiar with saturation when you talk about like the disk queue length. Is a really good proxy for how saturated your disk is. And errors is how many errors did that thing have. Read method, completely different. Read method, I came up with this name. It was actually a joke, but it stuck. But read method basically says requests, errors, and duration. You should monitor for every service, not every resource, but every service in your microservice architecture. You should be monitoring the number of requests, the number of requests that are failing, so the errors, and how long those requests are taking, the duration. And if you Google read method, there's tens of YouTube videos of me talking about it, so I'm not going to explain it any more than that. And then this new thing, this is what I'm really here to talk about, is this, I haven't given it a name yet, like, suggestions on a postcard. But this is like, you should treat your alerts and your monitoring system as an encoding of the expected state of the system. And, we'll come on to that in a minute. So the use method. You can get cluster and node level metrics. This is a cAdvisor, this is a node exporter thing. I didn't mention the node exporter, but it's probably the most commonly installed exporter. It scrapes procfs and sysfs and all sorts of different things in Unix and exports them as useful metrics. And this will tell you how much resources are used on your cluster. All these dashboards are open source, by the way. I'll give you a link to them at the end. An example of how you might do this. This is why I gave you an example of how you query Prometheus, because I'm going to give you some actual queries. This tells you CPU utilization. You can use this cool trick where you can use average and take one away from it, and it tells you the CPU utilization. So that's on the entire cluster, but you could easily group that by node and see it per node. And then saturation. So this is a bit of a cheat because this is a made-up metric, but no, the node exporter also exports load, which is just your run queue length. So what's more interesting when you start looking at Kubernetes is you don't have to just look at per node use metrics, right? Because you can start treating individual containers as a unit of resources. So you can take things like cAdvisor, which tell you this container is using 10% of one core, and then you can take metrics from CubeState Metrics, which says, but it's been allocated half of one core, and you can start to combine these two bits of data and say this is how utilized a single container is. This is where it gets really cool. This is where Prometheus starts to allow you to do things that are quite hard without Prometheus. Again, this dashboard's open source. I'll show you them in a minute if I have time. And this is how you do those kind of metrics where you combine these two different data sources, query. Now this is a bit tricky. Like, I don't expect you to be able to understand this. It took me a couple of minutes to write it down. But we're basically taking the container CPU usage, a rate of that. So this is telling us how much each pod is using, because I've grouped it by pod. And then we're basically doing a big join. This star on pod name group left is just a join. with some information that's coming out of CubeState Metrics, which is the labels that are associated with that pod. And then this is telling us the amount of resource that's used by label. And label is this concept. It's just arbitrary metadata, but you commonly use labels to group together pods at the same service. So this is starting to give you like service level resource utilization, which is quite hard to get in other systems. So red method. Red method is request error duration. Now, all of these services in Kubernetes export metrics with which you can synthesize red method. So this example tells you the request rate to the API server, for instance. Very simple, very straightforward. And from this, it's very easy, using the same method I showed you before, to get the error rate to the API server. And now you can tell if your Kubernetes API server is healthy, which is kind of cool. But actually, I promised to include some hard-earned lessons in this. This is probably the most useful alert I've ever written for a Kubernetes cluster. One of the nice things about Kubernetes is everything that talks to the Kubernetes API server generally includes the same library, which is the Kubernetes client library is written in Go. And now that Kubernetes client library exposes a metric, which is REST client requests total. And so given that single metric, I can tell how many requests clients are doing that are failing to talk to the server. And why is this useful? Because Kubernetes has this proper SSL certificate-based authentication, and most of the failure modes are you got that wrong. And if you monitor the server, you don't see request errors when the client failed to authenticate, because the monitoring tends to be at a higher level than that. But the client sees errors. And so if you want to know if your certificates are bad in your Kubernetes cluster, if they've expired, or if you've got misconfigured, this alert will tell you the component that is misconfigured and how bad it is. This is the one most useful thing I've ever had. So the method without a name. This is the idea that your alert expression should be invariants that describe the system. So the nice thing about Kubernetes is because you've got this higher level object model which says, I want an application, there should be 3 instances of it, those instances should be running. You've got these kind of clues that you can use to build quite abstract alerts that are still quite useful. And so, for instance, this one alert here tells you that will fire if you don't have n instances of your deployment running. And this will work for every Kubernetes cluster. Somebody comes along and they run, we've got an API server in Grafana Cloud, and you run that Grafana Cloud instance and you expect there to be 20 of them. And if there isn't, for whatever reason, that alert will fire. Similarly, if you want to know if one of your containers, one of your applications is crash looping for whatever reason, this alert will tell you. Show me another system where that is that concise, is that easy to write. This is, again, one of the most useful alerts. Kubernetes has a state which is called crash looping, but it's really sensitive, and generally it doesn't, it's not very tunable. And so this allows me to say, look, I can pick my window over which I say how many restarts I want to allow. This is much more flexible. So finally, a couple more examples. You might say in Kubernetes, I don't expect any of the pods, any of the containers in my Kubernetes cluster to have failed. I think that's a reasonable thing to say about a Kubernetes cluster. You either expect them all to be running or all to have finished running successfully. That alert is the really concise way of expressing that. You don't need those extra brackets. I don't know why they're there. And then finally, this is where it starts to get really cool. When you start running this big multi-tenant Kubernetes cluster and you've got multiple different teams within your customer competing for the resources of the cluster, you start getting into kind of quoting. You start to say, well, you guys over there, you can have 100 CPU cores. You can have 200 CPU cores. And then you really need to know, well, have I got jobs that are using all of their CPU cores, that are trying to use more? Have I provisioned the number of CPU and memories that I need to give my jobs correctly? And this kind of alert will basically say that. Actually, no, it won't. It's a completely different alert. I should have read the slide first. This alert will say the complete opposite. This will tell you if your Kubernetes cluster is big enough. Because this is basically saying, take all of the CPU requests. So this is the amount of memory we've told Kubernetes that a pod should use, and divide it by the number of nodes. Actually, the number of CPUs in the cluster. And make sure that that is more. Oh, well, it's an alert. So make sure that that is less, because it's alert, so it's the opposite way around, than the number of nodes in the cluster minus 1 divided by the number of nodes in the cluster. And what this is saying is, make sure I can always tolerate one node failure. make sure if a single machine in my cluster fails, I've always got enough spare CPU capacity that I can reschedule the jobs from the failed machine onto the other machines. Like, tell me of a monitoring system where it was that concise to write those really quite high-level alerts. You can tell I'm pretty pleased with myself, right? Right then, so I'm massively over time. I'm really sorry. We've just got one more section. I was going to give a demo and talk more about how you can go and do all of this really cool stuff, but what you can do is just go and read these links. This is a project shared by Frederick, the chap behind the CoreOS operator, and myself. And this is a canonicalization, like a standard format and standard library of all of the metrics and all of the alerts, all of the dashboards I showed you. They're all in there. And then if you want to install it, you've got two options. You've got the Prometheus operator, well, something called Prometheus and the Prometheus operator, which together will give you a full monitoring stack on your Kubernetes cluster, including the Kubernetes Mixin. Or you can use my library, which is obviously my preferred way of doing it, which is to use a tool called Ksonnet from Heptio, which I think is really cool because it's basically the same as the tool they use inside Google. And yeah, so they're the two options. But they both get you all of the metrics and all the alerts I just showed you. And if this was really interesting, or if you're asleep, the SRE book, obviously, this has probably been mentioned 100 times every meetup, but you've got to read it. There's a new one out that I haven't read. Apparently, it's quite good. There's this talk by a friend of mine called Bob, where he goes into a lot more detail, and he has a full 40 minutes, by the way. He goes into a lot more detail about what metrics each individual component in the cluster exports and what they can be used for and why they're useful. And then I barely did justice to Brendan Gregg's use method. And his website is incredibly useful when you want to know about it. So I would recommend, if you were inspired by any of the stuff or interested in any of the stuff I've mentioned, that's the first thing you should read. Thanks very much.